Hey guys, welcome back to channel. This is Remy from Do and Learn. So today we will have a short video on how to derive functions or expressions from a given circuit. So moving forward, let's say we have a small circuit like this. So when you try to analyze the circuit, we can see that we have three inputs. One is X, one is Y, one is Z. And we have some logical gates here, which finally leads us to the final output or function. So we are supposed to find out what is F1 here. So that is the question. So X is directly connected to this gate. So as of now, this value is X. So let's take what is Y. Now Y is connected to a NOT gate. So the other end of NOT gate should be Y dash or Y complement. Whereas Z is directly connected to this AND gate. So the outcome of this AND is Y complement and Z. So that's what we have here. So since it is Y complement and Z, so it is Y dash and Z. Now this OR gate takes two input, one from X and one from Y complement and Z. So the final OR gate's value is X or Y complement Z. So this is the final function or the output. So F1 is given by X or Y complement Z. So hope this is understood. We'll move to the next circuit. We have a simple circuit here. So again, X is connected to a NOT gate. So the other end of NOT gate should be X complement. Y is connected to another NOT gate. So this should be Y complement. And Z is connected to an AND gate. We'll come back to that. Now coming to the first AND gate. So here one input is X complement. The second input comes from Y complement. And you can see the third input comes from this line, that is Z. So finally the outcome of this AND gate is X complement, Y complement followed by Z. It's a product term. And let's come to the second AND gate. So here one input comes from X complement. The second input comes from, it's not Y complement, it's Y. Okay, the wire is connected before this NOT gate. So that is Y. And the third input comes from Z directly. So it is Z. So the outcome of this AND gate is X complement, Y followed by Z. Whereas the outcome of the third AND gate, one input comes from Y complement and another input comes from over here, that is X. So the final outcome is X, Y complement. Now all these three product terms are given as input to this OR gate. So finally the outcome of this OR gate will be X complement, Y complement, Z, or X complement, Y, Z, or X, Y complement. So F2 can be given as X dash Y dash Z plus X dash Y Z plus X, Y dash. Hope it's clear. We'll move to the next circuit. Okay, it's even simpler. So let's go for the first AND gate. One input is X and second input I have to find what it is. So Y is given as an input to a NOT gate. So the other end of NOT gate is Y dash. So this will be X into Y dash. Whereas here the other end of NOT gate is X dash. So X dash and Z is fed as an input to this AND gate. So that gives us X dash into Z or X dash and Z. So these two inputs are fed in as an or these two products are fed as an input to this OR gate. So finally the outcome of this OR gate is X, Y complement or X complement Z. So finally F2 can be represented as X, Y complement or X complement Z. So with the help of that, let's try to understand how we can draw truth table from any given expression. In a previous slide, what we have seen is how to write the expression when a digital circuit is given to us. So a digital circuit is given to us and we have found the output expression, or we simply call them as functions or Boolean functions. Okay. Now what we are going to see is how to draw the truth table for any expression or any given expression. So a truth table is a matrix table, okay, which consists of inputs and outputs for any expression or any Boolean expression. So to keep it simple, truth table gives the truth values of any expression. Okay. So let's take the first expression x, y, z dash. How to draw a truth table for this? So any truth table will have an inputs first of all as one of the columns and output as another column. So input is dependent on the expression, how many number of variables are there, based on the number of columns will vary. So as far as this first function is concerned, we have three variables. So the inputs given for this system is 3. Okay, so I can have one column for x, one column for y, and one column for z. Then ultimately I can have finally one column for output, which is f1. So moving further, so we can build a table like this. Your expression is f is equal to x, y, z complement. So I have three inputs here. So I have one column for each input. So let me write out all the different possibilities or possible combinations for this input. So when we have three inputs, we know in a binary system, the maximum number of combinations will be 2 power 3, that is 8. So let's write all the 8 combinations in a sequential fashion. So first I have 0, then I have 1. I'm just writing the binary version of numbers from 0 to 7. So when we have 3 inputs, we have 8 combinations. So those 8 combinations are from 0 to 7. Okay. So let me complete this. So first initially I had 0, then I had 1. These are binary versions of the decimal numbers. So then I have 2, then I have 3, then I have 4, which is 100, then 5, which is 101, and finally 6, which is 110, and the last combination is 7, which is 111. So we have written all the combinations here. Now we have to find out what is x into y into z complement. So you know that it's a simple AND operation between x and y and an AND operation between y and z. So in any AND operation, if you have all the inputs as 1 or all the values as 1, then the final outcome is 1, or else simply it's 0. If you remember right, when we have an truth table for AND operation, it is like when we have two inputs, so 0, 0, 0, 1, 1, 0 and 1, 1. Only when both the inputs are true, the output is true. Okay, or else all the other cases, the output is 0. So using this truth table for an AND operation, we can build the final function, which is x, y, z dash. So 0 and 0 and 0, that gives me 0. 0 and 0 and 1, that also gives you 0. 0 and 1 and 0, that gives you 0. 0 and 1 and 1, again it is 0, because I have at least one 0 in my row. Okay, so only when you have all three as ones, you will get 1. Apart from that, all the other combinations will give you 0. So this is how you form the truth table from an expression. First of all, you identify how many number of input variables are there for that expression. Then you identify the combinations possible. Then you list down the combinations in a sequential order. And finally, in the output column, you analyze the expression with the help of AND and or not, whatever gates that are present there. And with the help of the basic truth table of those logical operations, we can wind up the final answer here. So moving to the next one, we have x plus y dash z. Let's try to understand this. So function f2 is x plus y dash z. So I have again three inputs x, y, z. So what I do, I'll just write all the combinations. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, which is 4, 1, 0, 1, which is 5, 1, 1, 0, which is 6, and finally 1, 1, 1. Yeah, that's done. So since we have two terms in my function, let me try to find out what is y dash z first, and then I will try to OR this x with the temporary value what I have here. Let me call this as t. So let me have this as t is equal to y dash z first. So t is y dash z. So y is here. So y dash will give me 1. So 1 and 0, that gives me 0. Again 0 complement is 1. 1 and 1, that gives you 1. Now we have 1 in y, but we need y dash, which is 0. 0 and 0, that is 0. So here also we have 1 in y, we need y dash. So 0 and 1 is 0. Here we have 0. So y dash is 1. 1 and 0 is 0. So here we have 0, y dash is 1, so 1 and 1 is 1. I have 1 here which is 0, so 0 and 0 which is 0. I have 1 here, I need y dash, so that is 0 and 1 is 0. Now this temporary value has been found out. Now our job is to find out what is x plus t. So let's try to find out, and x plus t is nothing else but f2. Okay. So x or t. So I am going to compare this column with the last column what I have found out. So 0 or 0 is 0. Now 0 or 1 which is 1. 0 or 0 which is 0. 0 or 0 which is 0. 1 or 0 which is 1. 1 or 1 which is 1. 1 or 0 which is 1. And finally 1 or 0 which is 1. So this is your final output column. So we have drawn the truth table for this function f2 is equal to x plus y dash z. Let me take another example here. So f3 is equal to x dash y dash z plus x dash y z plus xy dash. So f3 is equal to x dash y dash z plus x dash y z plus xy dash. X dash y z plus xy dash. So let's go step by step. So let's try what is, let's find out what is x dash y dash z first. X dash y dash z. Then we will identify what is x dash y z. Then finally we will identify what is x y dash, and finally we will get f3. So let's have all the combinations first. I'll take a small shortcut here. So you can fill up in this way also. Yeah. So first trying to find out x dash y dash z. So x dash into y dash into z. So x dash is 0, y dash is, x dash is 1, y dash is 1, z is 0. So I have 0. So since we have z as one of the component here, and also it's an operation which is AND, wherever I have 0 for z, then ultimately 0 and anything is 0. So definitely I will have 0. Okay. So this is another shortcut way of doing this. Now we need to find out the second row, which is x dash y dash z. So x dash is 1, y dash is 1, z is 1. So I will get an answer 1. X dash is 1, but y dash becomes 0. So definitely the answer is 0. X dash is 0. Ultimately the answer is 0. Here also when x dash is 0, ultimately the answer is 0. Now moving here, so x dash y into z. So let's try with x dash. So wherever I have 1 as x, then definitely x dash will be 0. And 0 and anything is 0 for you. So you can say that these last 4 rows which has 1s for x will be 0. Okay. Or else in a natural way you can apply each and every value here and try to find out. But I'm trying to go with a shortcut method because we have already done with a straightforward method in your previous slides. I'm trying to do the shortcut method here. So then we have 4 more rows to fill up. So in these 4 more rows, when I have 0 for z, definitely the answer is going to be 0. So these 2 I can fill up. So in these 2. And we have only 2 more rows left out. So in this row, x dash becomes 1. Y is 0. So definitely the answer is 0. Here x dash will be 1, y is 1, and z is 1. So the final answer is 1. So moving further, the third column or the third output column, x into y dash. So wherever you have x 0, definitely the answer is going to be 0. So the first 4 rows, we have all 4 zeros. So the answer is 0. Now y dash, I have all the x's as 1. So now I have to consider y dash here. So 1 and y is 0. So 1 and y dash becomes 1. So it is 1 and 1. Again 1 and 1, that becomes 1. But here x is 1, y is 1. So y dash is 0. So 1 and 0 becomes 0. And finally the last row is also 0. Now we have to find out what is the total value of the final function, which is the output. So f3 is nothing else but x dash y dash z plus x dash y z plus xy dash. So we need to do OR operation between all the 3 variables here, all the 3 columns here. So we very well know that when we have at least 1 inside all the 3 operations, definitely the answer is also 1 because we are dealing with OR operation. So unless until I have 1 here, then I can put it as 0. So 0 or 0 or 0, that gives me 0. Here I have a 1, that gives you 1. Here it also 0. Here it is 1, 1, 1, and finally 0 and 0. So this column gives us the final output function. Hope it is understood. Now let's say the function is not given to us, just a truth table is given to us like this, like x, y, and z are inputs, and the final output, or they can even call it as f. Okay, so suppose if this truth table is given to us and they are asking us to find out the expression based on this truth table. Now how we are going to do that? So that's a shortcut way to do this. Try to analyze the output column. So this is the output column what I have. So in this output column I'll mark the rows which has 1. So 1 is the 1 in the output column represents that it has got a true output. Okay, so you take the corresponding variables and find out what you have. So I have 1 for x, I have 1 for y, and I have 1 for z. So ultimately the final function is given as x, y, z. Okay, so x, y, and z. Suppose, let's say, for example, if you have 1 here also. Okay, so what I do, I will circle these two ones. So I am having 2 rows which has 1 in the output. So first row is 100. So 100 can be represented as x, y dash, z dash, plus the second one that is activated is x, y, and z. So what we are doing here is we are selecting the ones in the final output column and finding the respective row, and in that row you can represent the input variables in the form of expression. So in this time, when we have 1 here, you represent in a direct fashion. When you have 0, you represent in a complemented fashion. So that's why we have 100 as x, y dash, and z dash. 111 as x, y, and z. Let's take this to the next example. Let's say you have this truth table and we are not given what is the expression. They have just given us the truth table, something like this function. Okay, and they have asked us to find what is f with the help of this truth table. So in this scenario, the truth table input is given, so the whole table is formed and given to you. You need to find out what is a function. So what we can do, you mark all the ones inside the final function column. So we have all these ones, and I'll go one by one. So let me take this first. So in this, the input combination is 0, 0, 1. See, this column is not here, so please forget this column, or even I can erase this column so that it makes things clear. So this one is activated, so this can be obtained by 0, 0, 1 for the input variables. So that can be x dash, y dash, and z. So when I have 0 here, I represent that with x. When I have 0, I represent that with y. When I have 1, I represent that with z. So when you have 0, you represent that with x dash. When you have 0, you represent that with y dash. When you have 1, you represent that with z. Okay, so plus the second one. So this comes from 100. So 100 is nothing else but x plus x, y dash, z dash. Okay, so we are trying to find a product term, product of the input variables. The product term is obtained when you have 1, you write the normal form of that variable. When you have 0, you write the complemented form of the same variable. Then for the next one, I will get it as 101, which is nothing else but x, y dash, z dash, z, plus the next one 110, which is nothing else but x, y, z dash, and finally we have the last one, which is 111, which is nothing else but x, y, z. So finally the function f is formed by x dash, y dash, z plus x, y dash, z dash plus x, y dash, z plus x, y, z dash plus x, y, z. So this is a huge function. If you want to simplify this, you can use your Boolean algebra, theorems and postulates, and finally you can simplify with lesser number of terms. That is left up to you. Maybe we can take another example. Let's say that this is the function given to you. So let me erase this so that it doesn't confuse us. So let's say this is the function given to us, and they're asking us to find out what is f3. So initially we mark the number of ones inside your output column. Then we take the corresponding row value. So row value 001. So we have to find the product term. So 001 represents x dash y dash z, plus for the second one I have 011, which is x dash y z, plus for the next one I have 100, which is x y dash z dash, and for the last one I have 101, which is nothing else but x y dash z. Okay, so maybe we can take certain things common here and try to modify or try to simplify the whole function, but ultimately this is how you get the expression from a truth table. So thank you for watching this video. If you really like it, please comment and share with your friends, and please do subscribe to our channel. I'll see you in the next video. Thank you.